Hello and welcome to the Unit 7 podcast on Section 15.4, Heterogeneous Mixtures. I'm Mr. Sakaguchi,
I'm Mr. Lin.
and let us begin. First thing we're going to talk about are suspensions. These are mixtures containing particles that settle out if we let them sit for a long period of time.
So an example of that would be concentrated orange juice. After a while, you just let it sit there in the fridge and it'll settle at the bottom. That's why you have to shake it. Suspensions are filterable because the pieces are large enough, and that is why they sink.
And the particles don't actually break up into the small particles that solutions break down into. Their large particles actually never break apart. And it's kind of illustrated on the figure on the right. We also have colloids, and these are heterogeneous mixtures with particles that are kind of intermediate in between suspension particle size and actual solution particle size.
Right, and as a result of this, these do stay floating around inside of a solution.
Yeah, they're basically small enough where the random motion of running into each other and solvent particles keeps it in solution.
Right.
And
Examples of these would be milk, fog, paints, bagels. I'll talk a little bit more about the fog later, actually.
And this is just a representation to kind of show you the comparison of size between solutions, colloids, and suspensions, excuse me.
So the reason colloidal particles or particles in general are floating inside of a mixture or solution is because of something called Brownian motion. No, we're not throwing baked goods through the air. What's going on is you're having, when these particles are inside of the solution, there's small amounts of energy inside of them, usually associated with temperature, but other factors like electrostatic forces that cause them to jitter around and vibrate. And this vibrational energy is what keeps these particles afloat. This is kind of similar to if, like at a graduation ceremony, someone throws a beach ball out there, and ideally the beach ball just keeps getting bounced up by people in the crowd. That's essentially what's going on with Brownian motion.
Yeah, so it's a result of electrostatic layers and kind of like opposite charges kind of pushing each other around. If you've ever done microscope work and looked under the slide and saw what you thought was something moving around, that's usually Brownian motion in action there. We can also interfere by using heat or stirring to basically cause the colloidal particles to clump together and then settle out a solution.
Right. One way to know the difference between a colloid versus a suspension or a solution. Colloid and a solution is something called the Tyndall effect, and this is where you shine a beam of light through both of your mixtures, and if it's a solution, you won't see anything inside of it because the light will go right through the particles and nothing results. Whereas with the Tyndall effect in a colloid, what winds up happening is the particles are large enough that they will actually reflect light, and as a result, you will see a beam of light as shown here on the right. I was talking about fog earlier. This is why you don't turn on your high beams on during a foggy night, is because what winds up happening is those fog colloid particles are floating there, and when the beam of light hits it, it'll reflect that light right back at you. You'll wind up blinding yourself and possibly other people near you as well.
That's right. That's it, I think.
Yeah.